Our next speaker is Amit from the computer science department of our Berlin University. And his talk is language models for that data-intensive problems.
Hi, everyone. Thank you for staying for the talk. Yeah, so I'm from the computer science department. First time for me in a venue.
They will see you.
What?
Yeah, so if you will stay there.
But who will change
people in Zoom
slides?
will, yeah. Maybe like sometime.
Okay, sometimes. Okay. I see. Right. Okay. Let me know like 2 minutes before I need to wrap up, or 5 minutes. I'll adjust the talk. Okay. So I wanted to talk to you about a language model and maybe a problem which is rather new for you. It's not that new for me, but now I'm
yeah.
Okay. Yeah.
Do you see yourself?
Yeah, I see myself, but now I'm like on the slides. Okay.
Just
okay. Yeah, so it may be new for you. It may be not as relevant as the earlier talk, but I think there are some similarities because many of us, since the emergence of AI and language models several years ago, are trying to think, well, how this can solve our research problems, right? And it happened before, and it will happen again, right, with other technologies. So currently it's AI, all right. So language models are a good text-related task, like writing text and answer questions, and this is great. But how well do they perform in tasks that are revolving around data, right? So take a data set, do something, and then answer a question. So how well do they understand data is also a good question. And the answer is, yeah, we already have some answers. They can speak, right? Because the language models at data at a basic level, right? They can do some basic stuff like understanding small tables. So here is a small task. There is a this is the instruction given the table below, which row and column has a missing value, and this is a representation of the table. Okay, which row has a missing value? Here you can see it right here. All right, and this is the response. Not a very good one by the model, but it does okay sometimes, right? So yeah, they don't solve anything perfectly, but they solve certain things sometimes. Another like very basic problem of that can maybe showcase that language model can understand the table. Given that table, right? So which column has the value 93, right? And we can see that in the table. Maybe it's a difficult representation for the human eye. Maybe in Excel it would be better to understand where is the value 93, right? But that's also a basic task that the language models are doing fine, right? Some additional tasks that LLMs can already do okay is answering questions about tabular data. It takes to SQL, right? So it's also a translation problem, like the in the earlier talk, like in Lean, but this time we have a text or maybe a natural language request, and we want this to be translated to a SQL query, right? A question about the data, annotating columns, the other way around, turning a table, like can the language model summarize the data from this table to a coherent sentence? Also an interesting problem. A very practical problem, which is the entity matching. I mean, this row in table A, does it match row J in table B? Also a problem that LLMs are okay at. Right, but yes, it's not that simple. But when the tables, I wanted to say large, but when the tables are not very small, then things are getting a little bit messy. Right? When the database or the queries are complex and contain multiple joins or nested queries, some database stuff, right? Then also language models are not so good at. So performance deteriorate. This is just a screenshot from a very recent paper about table understanding, and their definition of long table, right? I marked it up for you. Long table contain 7 or more rows. I mean, in the NLP community, this may be long, but I'm a researcher in the database community, and I think 7 rows is text, right? I mean, you can memorize 7 rows. Right, and this is considered difficult for the language model. All right, so in my talk today, I will try to present 3 problems. We'll probably have enough time to talk about 1.5. But this task may be more complex, right? Other than what is the value in the in cell ij, right? So the first problem is about generating tabular data. I mean, from scratch, from text, from whatever. I mean, can a language model generate table, right? So this is a practical problem. The other task is to investigate data, right? So we talked about text to SQL, right? So I can translate my data request into SQL, and the LLM is okay, but data investigations require a lot of trial and error, a lot of maybe a sequence of queries, and this is a different problem. And also, we already know that LLMs are very good at writing code, or in Python or in any language of your choice. But what if the code is dealing with data, right? So when the code has to consider the data in order to exist, right? Like in data science, I mean, when you try to build a machine learning model, right, from tabular data, like we did several years ago, right? I mean, it's not that we can have one model and just copy it around for all data sets, right? I mean, we have to look at the data and, I mean, derive data science operations and choose the right predictive model and do some data transformations, which are based on the data that we have at hand. Okay, so I will briefly touch the first subject, and then I want to focus on the second one, which is more, I think, relevant to, I don't know, maybe proof systems. Right, okay, so the first task, like in the Little Prince, I mean, can you draw me a table? Can you generate a table like this? Please generate the following table. I mean, describe the number of medals won by US art gymnasts in the Olympic Games and world championships together since 2001, right? So the knowledge exists, the facts exist. I mean, LLMs are trained over, billions of facts. I mean, they should know, I mean, all the facts individually, but can they generate a table containing all this data? So this is what we want. Sorry, this is not updated according to the recent Olympics. So is it a difficult problem? Yes, because tabular data must be exact and it contains numbers. LLMs hallucinate. So, I mean, this kind of contradicts the first point. Sometimes you have to integrate from multiple sources, like the example before. We wanted both the Olympic Games and World Championships, right? So it's like mix. Tables are often large, not, I mean, maybe even larger than 7 rows. Tables also contain aggregated data over thousands of facts, and we already know that LLMs are not as good at counting. So I don't know how good they are at calculating average or other aggregations. Okay, so there was no state of the art like in many problems, so we kind of did it in a joint project with these guys. Okay, so we curated a set of tables, 100 tables that we know that they contain accurate facts that will not change over time, and we had many properties for these tables for the task of generation, like this one, right? So we collected the metadata here. There is the description of the table. We annotated the columns. I mean, the column that contains the key in databases, the key means that it sets the row. I mean, it's a unique and non-null value. We have the size and even the popularity of the table. I mean, how common is the how common knowledge is are the facts from the table. right? And we had 100 because it was really a manual job. Right. So the basic approach was, I mean, very simple, very straightforward. I mean, please generate the table. I mean, this is the description of the table that we want. We ask the response to be formatted. I mean, in a JSON format, it doesn't really matter. We did check other formats, right? So this is what the LLM responses. Great. We also invented some two straightforward methods to deal with large data, but I'll skip that. So how did we check? I mean, whether the LLMs are good at this task? I mean, we compared the key. I mean, the keys that set the rows. We compared them with the keys that the LLM generated, and then compared the values, the non-keys. Right, and so we matched the keys, and if there was a missing key, there was a null for all the non-keys. If there was a hallucinated key, right, so there was an Olympic champion that is not existent, that the LLM was hallucinated, so we also generated nulls for all the data attributes, right, for the task, and we computed the precision and the recall and the F1. Okay, so the results are 0.25 F1 score, which was obtained by the Llama 3, like the very recent model by Facebook, the Meta. And our analysis showed that LLMs are not so good at this task. I mean, 0.25 is not so good. I mean, we expected better. And LLMs struggle with, and not just Llama 3, also other models, like the OpenAI model, GPT-4o, GPT-4. So they struggle with large tables, which contains more than 200 cells. Numeric data is a problem, and uncommon facts, of course, are a problem. It's difficult to retrieve uncommon facts and put them in a table. Okay, so we show that this is a difficult problem. So what can we do? So we as database people, we thought, I mean, what would a database do, right? I mean, a database would use a schema. It would have built a query plan, right? I mean, have a more structured approach to this task, not just generate the factual data from scratch. So for this task, we can use the concept of LLM agent, right? Because they are not so bad at planning. And also they can use tools like database tools. I mean, they don't have maybe to compute the aggregation themselves. They can maybe use, I mean, a function that can aggregate. They maybe don't have to do the complex operation of join, right? Because a database can do the join, right? So we just have to assign the task. I mean, which task will be performed by the language model and which will be performed by the database tool that the agent will use. Right, so there is a visionary workflow. We haven't deployed a full version of this yet. Right, so the first step would be in our plan is to infer the schema of this, right? So for the task of generating the US gymnast who won medals, right? So there may be several tables, the table of the Olympic Games, the table of the World Championship, the all tables medal, and the results table, right? And then we have to build this plan. So in blue, you see that they highlighted, I mean, this task will be performed by the language model. The union of the tables will be performed by a database agent, the join as well, and the group by, right? It's not always the case that the database will perform the group by. And also the retrieval may be more difficult. I mean, we may not be able to retrieve everything at once, right? And maybe in some websites, you're familiar with the concept of pagination, right? I mean, when you cannot see the entire results of a table on a website, it's divided to pages, right? So this is page 1, page 2. I mean, when you see the grades of all students and you have 250 students, it's the case in your department. But then you can choose the page size. So if you try to ask the LLM to retrieve only the first 50 entries of the table, and then you ask for the second 50 entries, then it's maybe not the best way to divide. And it doesn't perform well, but where you do some logical pagination, right? So maybe retrieve the athletes, retrieve the results by athlete or by championship, then it makes more sense, and then the retrieval accuracy is increasing. Right, and then we have to put everything together and get the results, right? So we are thinking about LLM agent that will have database tools that they will be able to use in order to generate accurate tables, right? So this is the solution that we are thinking of and trying out today. Okay, problem number one. Problem number two is investigate data, right? So can LLM answer investigative questions over the data, which require multiple queries? What is this task, right? So it's to explore, investigate the data in light of a certain goal using a sequence of analytical queries, like you can search, you can filter, you can aggregate, join, like in this data about Netflix TV shows and movies. Let's say an analyst is interested in finding a country with different viewing habits than the rest of the world, and here we have titles, Netflix titles, movies, TV, and we have the associated country, the duration, and all kinds of facts about the data, right? So this needs to be investigated, right? So there is not one query that can answer this question, right? So maybe a sequence of queries, maybe we can choose one country, study it, and then go to the other one and compare them, right? And it may take some time, maybe like you're working on the proof, right? You have some intuition, and then you go to another direction until you get it. So a good result, maybe hopefully generated by a language model, is that India may be a country that stands out in the data in terms of the rating of the titles and the type, right? Because in India, 56% of titles are rated TV-14, whereas in the rest of the world, the average is only 20, right? And also in the content type, right? In India, they mainly do movies, and in general, movies only constitute of 66% of the data, right? So this takes time and effort in order to answer such a question. And can language models do it? Let's see. So we gave ChatGPT. I mean, they do improve, and now they have this data analyst agent, and they do better. But still, right? They first plan. I mean, this is what the plan that the LLM suggested. Right, it suggested to filter the data set into TV shows and movies. So it means that it only focus on one aspect of the data. It has a predefined notion of what is atypical, right? It was a maybe soft definition. I mean, we didn't exactly know what is atypical is. I mean, what do you have to do in order to stand out as a country in this data? So it wanted to calculate the global percentage of TV show and movies, go by the country and calculate the data for each country, then compare all percentage and probably return all these countries which have above average scores, right? So here it defines what is atypical. I mean, if there is a difference of more than 10%, okay, this is considered atypical, right? So is it good? I mean, we don't know, but we checked. So we did a user study that compared these results. I mean, we generate, I mean, the answers and in tables and show them to actual users, but they didn't like it. They didn't like this response. So what did we do before language models? I mean, there is this field of, I mean, we try to have the analyst and the data scientists, I mean, find stuff in the data. And we did, I mean, we did work on systems such as like recommender systems for analytical queries, generating insights and visualizations, generate maybe full exploratory sessions, a sequence of queries, right? And the way that this used to work is that we defined what here is an insight mining system from several years ago, right? So it mines the data and surfaces insights, right? So what is an insight? It's a template that contains some of the data, some aggregation, and a utility function, right? So this trend here is a template of an insight, right? And the utility of a trend is higher if the trend is steeper or if the slope is steep, right? So this is a good insight, right? Because it shows a very significant visible trend in the data, and if all bars were, about the same size, then the trend was not as good, right? So we can search, combinatorically search for all these insights, right? Candidate insights, and then give them a score, and then return those with the best scores. Right. So how do we embed language models into this, right? So the language models, they do have this analytical mind, right? So they think like humans, but the problem is that they cannot work like optimization systems. They cannot, make many queries on the data and get the results, right? Because they forget and so our vision is somehow to combine them, right? So the language model can help us planning, right? It's we already know that it's pretty good in planning. So it can. So if there is a huge search space, right, for all the sequence of queries that can be deployed, at a certain point in order to solve this data investigation problem, right? So we can use the LLM to narrow the search space, right? So we don't have, so not all sequences are good. A good sequence is a sequence that at some point it filters the data by a certain country, right? Because we are looking for a typical country. So all sequences that does not contain such a filter are irrelevant for us, right? So LLMs can infer that, right? So and it's a good thing, right? They can also set, so if we define an optimization problem, we have the optimization goal predefined, right? So maybe the LLMs can help us in defining this optimization problem, the optimization goal, in order to better search for the right sequence of queries. They can give us instructions, right, to filter. If we choose to perform a filter or go by command, they can assist us in choosing the parameters in light of maybe the previous operations that we did, right? They can help us also eliminate irrelevant columns. So if we are looking for a country which may be interesting, so the columns director, cast, and title are irrelevant for the search, right? So we are talking about some kind of augmentation of a language model and this optimizer that we built for databases, right? And together they form an exploratory session, which is then summarized into the nice summary that we saw earlier about the results, that is actually stating the insights. Right. Good. So we do have like a skeleton implementation for that, in which I'll finish with this remark, because we also invented this language, which is based on some sort of SQL, but it's not for one query, but for a sequence of queries. And we did want to use the LLM to translate between the natural language request, which is find a country with different viewing habits, right? We wanted to use the language model to translate to our language. Our language was a specification language that we used a deep reinforcement learning optimizer in order to which considers also these constraints, right? And it's also a language that we invented. The internet has maybe zero lines of code of our language existing. And we did rely on the fact that it knows Python, right? So we first formulated our problem, our language as a Python code, and then translated the Python code into our language. It worked pretty well. All right, so I'll wrap up, and we show, of course, that the LLMs are, so this is a good start, right? But there are maybe other cool ways in order to merge this kind of optimizer together with the LLMs, right? You can, there are maybe several, and it's a good point to brainstorm and discuss. Whether to put the LLMs inside the optimizer or give the optimizer to the language model, we don't know yet. Yes. So in conclusion, they already speak data, but pretty limited. In order to make them fluent, we need complex architectures, maybe LLM agents. We also need safeguards, right? But this is maybe for another talk.
What's your prediction here about timing of like gathering them together, LLMs and knowing data well? I mean, what's the prediction of increasing quality here?
So increasing quality, it's a very good question. So we believe that not so. So we can have this talk again next year, and all results will be slightly better, right? Because the LLMs.
Or dramatically.
So we believe it will be slightly because the LLMs. So the problems with data are inherent. So it's not that you can improve. I mean, you make the network bigger, and then it will somehow read and understand the data, right? So or it will know how to optimize or make a long sequence of queries and find it in a search space of millions of queries, right? So the solution goes toward this augmentations of LLMs and tools, right? So if we know how to merge them correctly, I mean, embed the LLMs into the optimizer and vice versa, we'll have better systems. And I think it's true for other fields that try to solve complex problems that LLMs are not natively good at. This is my take. All right.
Yeah.
So thank you for listening.
So do you have other questions? Let me see. Yeah.
So can an analyst give some kind of reference book, with the movies and then ask it to analyze and prepare a table?
Right. So it's a good question. If other than the data itself, is there also references?
Documentation about
There is also, previous knowledge. So let's say I'm an experienced analyst and I already know this data set. I research it for another problem, right? So I can somehow transfer this knowledge into my current task, right? So we also need to transfer this knowledge to the language models, right? If we want them to be good analysts. And that was a problem before we used LLMs. I mean, how to model, how to build a data model that captures both the data and some assumptions on the data. Right. So there is an active line of work about this.
I guess my question was somewhat different. For example, can you give it the reference book properties of methods, whatever, and then ask it to make a table out of it?
Oh, okay. So I see. Right. So this is regarding maybe the first part of the talk where we generated tabular data, and we did an experiment of using the only. I mean, no, we did it without reference, right? But a more maybe practical version would be, let's say that we have a bunch of text, right, and we want to somehow push this text into the table, right? So so right now there are retrieval augmented generators, right? That the language model first obtains some contextual information and then only generates the answer, right? In the context of table, this will be, of generating tables, it will be a bigger problem, right? Because usually when the language model tries to answer a question which requires some, I know, searching online and stuff, I mean, it gets a limited number of documents, right? And here, because we want to generate large tables, the size of these documents will be very big. So this is a problem that we want to deal with maybe after we deal with the simpler problem of just using the language model's mind, right? Okay.
And those LLM agents also not only create the SQL command, but also run in the background with the actual data, and then print the output
Right. So the LLMs can, so we want to give them the ability to do it. I mean, several years ago when deep reinforcement learning was, we did it with a deep reinforcement learning agent. We let an agent, a neural network agent, we hooked it to a data set and allowed it to perform queries, right? And then perform a lot of queries and then maybe find the optimal ones, right? I mean, and in the context of language model, this is a little bit problematic because if you wanted to perform in a trial and error way, right? Maybe 10,000 queries, then the size of the context is limiting, right? So we would need some sort of ways to summarize, right? All the results, all the history, right? And that's an open problem as well.
Right.